All right. So I'm recording the lesson right now. Let me tell you what an interval is. An interval, guys, is a range of values from a lower bound to an upper bound. For example, when I give you this 7.25, comma 10.50, this is called an interval. How many values are there inside this interval? Infinitely many values. All the numbers from 7.25 all the way to 10.5. Decimals, not decimals, etc. So this is what an interval of values. So if I tell you, for example, you can come and see me between 1 p.m. and 2 p.m. That means you can come anytime as early as 1 and until 2 p.m. How many times, just you can select from there? There are so many times that you can select between 1 and 2. So an interval is a range of values that starts with the lower bound and ends with the upper bound. Here is an interval, guys. The mean is between 3.8 and 6.2. That means the mean can be any value as low as 3.8 and as high as 6.2. It ranges from 3.8 to 6.2. The question, guys, is how can I find the middle value of an interval? So if you have an interval of values from 3.8 to 6.2, where is the middle of the interval? Does anyone have an idea on how to find the middle? What would you do?
Add and divide by 2, no?
Exactly. The middle is the average. You just add them up and divide by 2. So the middle will be exactly. The middle value will be 3.8 plus 6.2 divided by 2, which is going to be 10 divided by 2, which is 5. And let me show you a sketch, guys, that makes it make sense to you. Watch. This is 2, this is 4. This is the interval from 2 to 4. Where is the middle between 2 and 4? Does everyone agree that it's the point 3? Because 3 sits right in the middle, right here. Now, let's say if what you said, guys, makes sense. If you add 2 plus 4, what do you get? 6. If you divide it by 2, what do you get? 3. That makes sense. So you can see a visual that it makes sense to add up the lower bound and the upper bound and then divide by 2. Your turn. Let the mean be between 105.67 and 118.59. Represent an interval in the number line. What's the value that is in the middle of the interval? So value in the middle will be, guys, 105.67 plus 118.59 divided by 2. And be careful when you use your calculator, you must use parentheses, or you can do the top first alone. But if you want to do it all at once, you must use parentheses, guys, first. So it's going to be 105.67 plus 118.59. And look, I close parentheses and then divide by 2. 112.13. All right. This is an interval. So intervals can be written like that, guys. The mean is between 3.8, 6.2. That's an interval of values. Or you can put open parentheses, close parentheses. This is also an interval. It's a range of values from 0.124 to 0.498. Again, the question, what's the value in the middle? So the value of the middle, I've done the work to do it. You're just going to do 0.124 plus 0.498. Maybe you're wondering why the middle value is very important. You will see that shortly. Divide by 2. And let's do it here. open parentheses, 0.124 plus 0.498, close, divide by 2, 0.311. We got one more to do, and then we can go to chapter 6, guided notebook. If 6.48, 15.84 is an interval on the number line, find the value that is in the middle. Okay. Can you guys do that for me, please? I'll write it down here. So it's going to be 6.48. Just get used to doing that on the calculator. When you start your homework online, these are pretty much the very first questions that you're going to see. But you will learn what is the middle, what do we call the middle later. So let's see, what would that be? So that will be, guys, 6.48 plus 15.84. You notice I didn't use parentheses here, but look what I'm going to do. I'm going to find the answer first, which is 22.32, and now divide by 2. You can do that as well. 11.16. So this is how you find the middle. So now you learn something, guys. Even in statistics, if you are given an interval of values from 2, and you are asked to find the value of the middle, you just add up the 2 values and divide by 2, you get the middle value, which is the median or the average. Okay, that's what you need to know. This is all the algebra, guys, that you need to grasp chapter 6. Now I'm just going to display the handout from chapter 6. Okay, chapter 6, guys. This is the beginning. What we have done from chapter 1 through 5 is mainly descriptive statistics. Now in chapter 6, guys, you're going to learn how to interpret data and how you're going to analyze data. So chapter 6 is important, but the most important chapter in the entire book is chapter 7, when I introduce you to hypothesis testing. And this is what I've been telling students, in the past. If you grasp chapter 7, you can guarantee that you're going to pass the test that pertains to chapter 7 and the following, and the chapters that come right after, and that will guarantee that you're going to pass the final exam. So I cannot stress how important, guys, is chapter 7. Chapter 6 is important, but chapter 7 is really the deal breaker, for this class, because everything else from now on, it's going to pertain, to chapter 6 and 7 all the way to the end of the semester. So I'll make sure to spend enough time covering chapter 7 when we get to it, and you're going to have tons of handouts and resources and videos to grasp it, because once you pick it up, you're going to see the remaining chapters and the course are just a continuation of what you learned. So let's continue working on chapter 6. You already know what an interval is, because I already explained, what an interval is. An interval is a range of values from a lower value to an upper value. Okay, we're gonna do some exercises, introductory exercises, before we begin with 6. Express the following using expressions or inequalities. So I'm giving you something in words, guys, and I would like you to express it using numbers and symbols. The true mean is between 112.5 and 127.6. The true mean, guys, which is the population mean, we use this symbol, which is a mu. So when he asks you to write this using symbols, all you have to do, guys, is put mean is between 112.5 and 127.6. That's how you interpret this. Any questions? Can a student tell me how to do B? The proportion of students is between 45% and 47.8%. What letter would you use for part B, guys? You're not going to use the mean because he didn't say it's the mean. Any suggestion for a letter?
Is it X or Z?
Not X and not Z, because X is data value and Z is a Z score. He didn't say Z scores here. What would be an appropriate letter to use for this?
Would A be an appropriate letter?
Something that's linked to proportion.
P?
P, very good. So for proportion, we're going to be using P, and this is going to be throughout, the book. Every time you hear about proportion, it's a letter P. So we'll use P for proportion, and 45%, it's good to interpret it as a decimal, guys. So to change a 45% to a decimal, you just move the decimal point 2 digits to the left and drop the percent sign. So it will be 0.45, and 47.8%, guys, it will be 0.478. So 0.45, you can put the 0 here, and 0.478. So now you learn something new. Every time there is a reference to a proportion, it is a percent, we use the letter P. It's a probability, guys. Proportion, percent, probability, it's the same thing. We use the letter P. The mean age, not aged here, is between 21.15 and 23.5. So now I'm saying mean, guys. It's not up to you to use P now. It has to be the mu, the sign for the mean. This is the true mean. True mean means a population mean. So that will be mu is between 21.15 and 23.5. If you ask me if the interval includes the lower and the upper bound, no, it doesn't include them. So between without, the equal sign here. So mu is bigger than 21.15, but smaller than 23.5. Okay, guys, your turn now. Can you help me with this? Interpret the following in words. How would you read this in words, guys? So what would you say?
The mean is between 28.
True mean, yes. Or the mean, yeah, that's fine. The true mean is between 28.5 and 30.2. Okay, would someone help me with this one? Number 2. These are all, guys, tools that I'm preparing, just to learn the material. So the more you comprehend, just what I'm doing now, the easier it's going to be later. You will see. So what do I say here? True proportion?
The true proportion is between, would you say 45% or 0.4?
Yeah, 45%. When you use words, it's good to say it in percent for a reader. People will get it better rather than saying 0.45. They have to process 0.45. They don't understand it, average readers. So it's good to tell them in percents. It's between 45% and what? 51%. Number 3. Find the midpoint of the interval 30-37. The midpoint, guys, is the middle value. That's what I was talking about earlier. So can you remind me, guys, how to find the midpoint?
Add them together and then divide by 2.
That's it. There you go. Before we can do that, none of them we use now. Chapter 6.
That is really choppy.
All right. So now let's do an introduction of section 6.1. Just like you to watch me doing the presentation and introducing confidence intervals. All right. I don't know, guys, if you've seen that on TV, on CNN or Fox News already. They're making predictions of who could win the election. And probably you've seen something like that. The most recent poll show, for example, that Biden is might get, let's say, I'm just gonna make this, get 58% of the votes. And at the bottom, guys, there's something that you don't see. They do it in fine print. Margin of error is a plus or minus 4%. They show you the 58% in bold-faced, letter. You can see it, it's visible. But at the bottom, they do mention it, sometimes they do mention it, but they mention this quickly. Margin of error is plus or minus 40%. Does anyone know what that means? Most people would look at it and say, well, Biden is going to get 58% of the votes.
That means it could be 54 through 62, correct?
Exactly. The margin of error, guys, the plus or minus 4%, it will tell you that actually, no, it's not 58%. It could be as low as 58 minus 4 or as high as 58 plus 4. So as you said, a 54% to 62%. From 54% to 62%. This is a confidence interval, guys. So what they show you a confidence interval without telling you that it is a confidence interval, because people don't understand what a confidence interval is. Listeners to CNN, Fox News, if they didn't take a stat course, they're not going to know what a confidence interval is. So they just say margin of error, mention it, but actually it is a confidence interval. So it is possible that Biden will score as low as 54 all the way to 62%. But you cannot just say it's only one value, but they do show you only one value. This is an example of a confidence interval. And if you write it down, guys, you will write it like this: 0.54, comma, 0.62. If you want to write an inequality, it will be a proportion, guys, because it's a percent, not a mean. So we'll write it like this. And this is called the margin of error, which you're going to learn about today. You're going to learn how to do it. If you recall, guys, just 10, 15 minutes ago, I asked you to find something called E. E is the margin of error. So you can link, just what you did earlier with what we're going to do now. All right. Let's continue introducing this section. Let's say, guys, we have 15,000 students at the college. So please pay attention to this introduction, because it's going to give you a very good idea about confidence intervals. I wanted to figure out the average age of students at my college. It's not going to be possible, guys, to go and interview 15,000 students and ask them for their age and then come back and add all those 15,000 ages and divide by 15,000. That's a lot of time, a lot of money, just to do this kind of research. So what we do, we're going to pick a sample. So we pick a sample of 50 students, or let's say 30 students. And we ask them for their age. So they reveal their ages. Then we add the 30 ages and divide by 30. And we get, just the average age from the first sample is, let's say, 19.7 years. Here's my question to you guys. Can we conclude that the average age of all students at the college is 19.7? Yes or no?
No.
Why? Because this is based only on what? A sample of 30 students. I mean, it's an estimate, but how accurate this estimate? Well, another students can argue with me and tell me, well, Mr. Bazzi, I don't think we can agree that it's 19.7 because I went and interviewed 35 students at random. I pick them at random on campus and I ask them for their ages. So I got 35, answers. I added up all the ages and divide by 35, and this is what I got the average age. $20.5 years. So which students which sample we're gonna go with, the 19.7 or the 20.5? Neither one. So, but this is an estimate, and this is also an estimate. And then a third student said, well, I don't agree, just with both estimates. I went and surveyed 40 students. And I wanted to find the average age from the sample. And that students turned out to have 21.2 years, 21.2 years old. That's the average. So who's gonna be right? The one who came up, just with the 19.7 as an average? They are all called estimates of the true mean, but none of them is actually the true mean. 19.7, it could be, but we don't know. 20.5 could be, but we don't know. The 21.2. So what I'm trying to tell you guys, it's not possible to estimate the true average age of a student by finding only one number. It's not gonna work. The only way, guys, to find the exact true mean of all those 15,000 students is to go to the college records and survey and get the data from every single student record, add them up, the 15,000, divide by 15,000 to get it. But we said this is not possible. Here I'm talking about 15,000 students. We could have a data that has hundreds of thousands of students, and to do this, that will be an effort, that takes a lot of time and money. So we try to estimate it using samples. So we did 3 samples. We got 19.7, we got 20.5, we got 21.2, and they are all different. What I'm trying to tell you guys, in order to estimate the mean, you cannot estimate the mean using one value, but we can estimate the mean using an interval of values, a range of values. So the range of values could be, let's say, as low as 19 years and as high as 22.5 years. I'm making this up. So now you can say the true mean, it is possible that true mean can be as low as 19 or as high as 22.5. Just like the CNN poll, guys. The true proportion, the true percent of votes that Joe Biden could get would be as low as 0.54 or as high as 0.62. So, but what is the actual proportion percent of votes that he's going to get? We don't know. It could be as low as this, as high as this, but which one? That's not possible, just to find. And the same thing for the age. So the true age, the mean age, I can put the mean here, could be as low as 19 or as high as 22.5. Now, which value, 19 here, sorry. Which value from 19 to 22.5 is the true mean? I don't know any of those values. That ranges from 19 to 22.5. The only way, guys, to find information about the population, exact information, is to survey the entire population. And we know surveying the entire population is not possible. You can't just do that. We do the census in the US every 10 years. We've done it, just this year in 2020. Census is a survey of the entire population of the United States. The only reason why we do it, every 10 years, because it takes 10 years even to prepare for it. And they're still not done yet. They're still working on it. They won't be done until the end of the year. Especially during COVID-19, it makes it even, just more difficult to do the census of the population. So this is what we call a confidence interval. It's a range of values from 19 to 22.5. or 0.54 to 0.62. And I'm going to show you something interesting about, just the margin of error. If you see in the CNN poll, let's say, they were saying like Biden will get 52% of the votes from a survey of 10,000 registered voters. When you look at 52%, guys, you think that this guy is a winner. He's going to get more majority. Well, if he gets more than 50%, he wins. But watch, what about if the margin of error was 3%? Can you tell me what the true interval will be now?
0.49.
So 52% minus 3%, it's 49%. And 52% to 3% plus 3% is what?
55.
From inside the interval, guys, do you agree with me that there is a chance that Biden will lose now? If he gets, is it possible that inside the interval he gets less than 50%? Yes or no? Yes. It could be 49.5%. If he gets 49.5%, which is a value in the interval, he'll lose. So the 52% will give you a first impression, oh, wow, he's above, the majority. But with the margin of error, guys, and imagine if this margin of error was 5%. Look what happens if this was 5%. 52 minus 5% is going to be 47%. And this is going to be 57%. So look, he got values inside the interval that probably caused him to lose the election. And he got some values probably would be in favor of him to win the election. So you see, the 52% doesn't mean anything without a margin of error. And we're going to learn, guys, how today to find the margin of error and construct those intervals. So 47% to 57% have values that are less than 50%, and it does have values that are more than 50%. So it's a win or a loss. Both exist, inside this interval. Whereas inside this interval, guys, no, the percent is always a majority. Look, a 54% to 62%. So you can pretty much guarantee that the person, will gonna make it inside this interval, but not inside this interval. It depends always on the margin of error. Okay? Any questions so far? So let's continue with this. I just need to do this introduction, guys, so you can have a feel of what intervals are like. And once I finish the introduction, we'll go to technical and show you how to find those intervals. So guys, let's say I'm gonna work on the average age of students at the college. At HFC. So let's say we pick a sample of size 45. So N was 45. And we surveyed 45 students, and we came up with a sample mean of 20.7 years. So this is from review, asking 45 students, how old are you, etc. We came back, we got all the ages, put them in L1, and we found X bar. Now, why I use X bar, not to mu, guys, because this is a sample. This is called sample mean. Okay. Then I went to the office records, guys, and they told me we already done some research and we were able to compute the actual average age of students. So I got the information. I was lucky that I was able to get the information from the college records. They told me that the actual age of students at our college is 21.3. This is not possible to get, guys, but let's suppose I know it. What do you think? This is an estimate from the sample, and this is the actual value. If you do the difference between the actual value and the estimated value, what would you get?
0.6.
Yeah, 0.6. Does anyone know what 0.6 is? It is the,
Margin of error.
what is it? What did you say?
The margin of error.
This is the margin of error, guys. So the margin of error is the difference between the actual value and the estimated value. You guys were not gonna know this to find the margin of error this way, but just telling you, if you know the actual value and you get the estimated value, the difference between the two is called the margin of error. Okay, so difference between estimated value, which is the sample value, and actual value, which is the population value, is called the margin of error. And in the book, guys, they call it E. So E is the difference between X bar and the mean. X bar is the mean of the sample, and mu is the mean from the population, and E is the difference between the two. This is how, this is what the margin of error is. Now, let's suppose now we don't know the actual mean. And indeed, in reality, guys, we don't know. We don't know anything about the population. We try to estimate the population. So here's what we do. We have the average age, X bar, which is 20.7. That's X bar. We need to construct an interval. Now, would you guys agree with me that the actual value could be a little below 20.7 or what? Because 20.7 is the sample mean. The actual mean could be below 20.7 or could be above 20.7. So your interval, guys, could be 20.7 minus something and between 20.7 plus something. And that something, guys, it's called the margin of error. So the interval that we're gonna try to find is 20.7 minus the margin of error and 20.7 plus the margin of error. That would be a confidence, this would be the interval. So the challenge is, how do I find the margin of error? And to prove my point, guys, when I showed you the CNN poll, I showed you, for example, the 58%, and then I showed you the margin of error, plus or minus 4%. And I ask you, what would be the actual values? And you guys, you told me 58% minus 4 and 58 plus 4. And it's the same thing. The 58% is the sample proportion. It's from the sample of 10,000 registered voters that they interviewed. They got 58% to say, yes, we will support, for example, Biden or Trump. And then the plus minus 4. And here's, it's the same thing, guys. The 20.7, it's an information that we got from the sample. If we subtract the margin of error, and then we add the margin of error, we get what we call the interval here. So my task for today, guys, before we wrap up the session today, is to show you how to construct those intervals, how to find the margin of error. And once we do it once, guys, you will learn, you know, just how to do it every time. So this is still an introduction. How do you find? So our task is to show you how to find the margin of error. Okay, so that would be the next step. Before I go to the next step, I want to introduce what we call a confidence level. When I tell you guys I'm 100% confident What is it that I'm trying, to say here? That, okay, I'm 100% confident that I'm going to do this. What does that mean?
That's absolutely the thing that's
absolutely it's going to happen. Absolutely, it's going to happen when I say 100% confident. So I could tell you, I'm 100% confident, guys, that on the next test, that you're going to score between 0 and 100%. But then when you listen to my statement, it said it didn't add any value. We know the lowest score is 0 and the highest score is what? 100. But can I make this statement? So there was a statement that I made, but you think it's an empty statement because it doesn't add, you bring anything new. You know your score ranges from 0 to 100. But can I say I'm 100% confident, guys, that you're going to score between 80 and 100% on this test, on the next one? Yes or no? Well, if I say I'm 100% confident, guys, that means this is going to happen. And then I will be liable, just for what I said, that everybody is going to get between 80 and 100%. How do I know that? What about if the student did not prepare well for the test? How this is going to guarantee that the students is going to score 80% or higher? So that can't be the case. So I cannot use 100% confidence level, guys. There is no, when you want to make statement, there are no such a things, in statistics to use 100% confidence level. So we're going to lower the confidence level. I could say I'm 90% confident that students will score between 50% and 100% on next test. So based on what I saw on the first test, most students score in the range of 50 to 100%. I can make this statement, guys, and say that I'm 90% confident, not 100% confident. Because once I say I'm 100% confident, guys, that I'm telling you this is going to happen for sure. When I say 90% confident, I'm allowing a 10% chance room, just for an error, guys, to happen. So I'm not 100% sure. It's just 90% confidence. Is this a high level of confidence? Yeah, it is a high level of confidence, 90%. But there are some other high level of confidence that I'm going to share with you and that we will be using in this chapter. There is a 95% chance. I'm 95% confident that students will score between 30% and 100% on the test, on the next test. You see, my confidence level is high. What happens to the scores, guys, when I displayed a higher confidence level?
The range got larger.
Exactly. You have to, because I'm given a high level of confidence. I have to give enough room, guys, because I can't. I'm 90% sure that students will get between 50 and 100% with a 10% room, just of error here. But if I have a higher confidence level, guys, I need to widen the interval so I don't make a mistake, just by making this statement. Now there is a 99% confidence level, but no 100%, guys. I'm 99% confident that students will score between 20% and 100% on the next test. My confidence level went so high, guys, almost error-free. Well, if it is almost error-free, guys, I have to allow a room for you guys to score as low as it can be possible or as high. From my experience, I never had any students score below 20%. So I was safe, just to put the lowest score to be 20% to 100%. There is no such a thing called 100% confident, guys. Unless if you have the entire population, you cannot do 100% confidence level. If I want to make, just 100% confidence statement here, it's going to be a very weak statement. I'm going to tell you, I'm 100% confident that students will score between 0 and 100% on the next step, on the next test. And that doesn't bring any value. It doesn't add anything, there, because you already know that your score is going to be as low as 0, as high as 100%. But as you can see, guys, when you increase your confidence level, your interval will always widen. It has to widen, guys. It will become, just more and more values to put inside the interval. So when we create, those intervals right here, guys, we have to create them at some confidence level that we will tell you what the confidence level in the problem is. 90%. The common confidence levels are 90%, 95%, and 99% confidence level. In medical fields, guys, when a pharmaceutical company wants to seek approval for a new medication, the FDA requires the study to be done at the 99% confidence level, because they cannot allow it to be at 90% because there is a 10% chance, just a room of error. But here, 99%, the chance is only of not being accurate is only 1%, guys. So that's why they require the studies to be done at the 99% confidence level. The most common confidence level, guys, is the 95%. Most of the research studies, etc., you will see it done at the 95% level. I know now I introduced this, is still not making a lot of sense to you how we're going to put it together, but you will see in a moment how we're going to put all of this together. So in summary, before I show you an actual problem and how to construct those intervals, in order to construct an interval, guys, we need the following. We need sample size. How many in the sample? It's called N. We need the mean from the sample. Which is called X bar. We need a standard deviation. And we need confidence level. And your confidence level, as I said, guys, it could be a 90%, it could be a 95%, and could be 99%. When you have the sample, guys, you can find the mean. You can find the standard deviation. And he will tell you what the confidence level is. And here's how we're going to construct the interval. If he asks me to construct an interval for the population mean, it's going to be like this. He gives you X bar. You're going to put the mean here. You're going to do this. You're going to put X bar, and you're going to put X bar here. You're going to minus the margin of error, and you're going to add the margin of error. So all I need to show you guys and how to find the margin of error. If I can show you how to find the margin of error, all you need to go, take that X bar value that's given to you, subtract E, take the X bar value that's given to you and add E, and you are done, and you can put in the answer, and this is your confidence interval. Now, how do you find E? Let's show you how to find E. Guys, Z is, that's the formula for Z. If I make this instead of X as an X bar, guys, what would change in this formula? Okay, this is for extra credit, guys. The person who answers will get 1 point toward the next test. Something has to change as well if I change X to X bar.
Would it be the sigma?
What is it gonna change in there?
To the sample.
Very good. When we work with X bar, your sigma is no longer sigma. I just talked about it when I reviewed chapter 5. And who's this? Who's talking?
Sharia.
Sharia. Okay, I'll take a note of this, Sharia. It's going to be sigma over square root of n, because when we did chapter 5 and we did the central limit theorem, when we work with samples, guys, and we work with x bar, our standard deviation become a smaller one, and it's called sigma over square root of n. Okay, guys, the x bar, the difference between the sample mean and the actual mean, we call it the margin of error. So look, this is the margin of error here, E, divided by sigma over square root of n. Now I want to do a little bit of algebra with you guys. If I want to solve for E, how do I solve for E? Using cross multiplication. So E times 1, guys. If you have something like that, 2 over 3 equals 4 over 6. You can say that 3 times 4, guys, is 12 equals 2 times 6, which is 12. And same thing here. So I put Z over 1. So E equals Z times sigma over square root of n. And this is the formula for the margin of error. And we will be using this formula, guys, to show you how to find the margin of error. I don't know if you recall, guys, when I was doing an algebra review, I asked you to do something like that. And look, it's pretty much it. This number times that number divided by a square root. That's why, the reason why I did this earlier, guys, because there is a formula here just like that. So this is the formula for E. Okay. So now, x bar minus E, x bar will already be given to you guys, x bar plus E. Once you learn how to find E, you plug it in here, you plug it in there, and you get your interval, and then you can answer the question. Let's put this into practice and show you how to find the confidence interval in the first example in section 6.1. So I'm going to go to section 6.1. All right. We're going to do example 2. And I will review example 1 once we do example 2. But example 2 has steps, which I'm going to walk you through it. Okay. Construct a 95% confidence interval for the population mean mu. So you guys have the confidence level. As I told you, he will always give you the confidence level. So confidence level C, we call it C, guys. It's 95%. And we'll see how we're going to use this one. Assume that the population has normal distribution, so it's bell-shaped. A sample of 25 randomly English majors. So what does the 25 represent, guys? What symbol? N. All you need, guys, even when you use your calculator, you need to know what each number represents as a symbol, because when you plug in the values into a calculator, the calculator is going to have a prompt. What is N? What is the confidence level? What is X bar? So you need to be able to enter them properly. So a sample of 25 randomly English majors has a mean test score of 81.5. What is the 81.5, guys?
The mean?
X bar.
X bar.
Oh,
It is always X bar, guys, because we don't know what the population mean. Look, he's asking me to find an interval for the population mean. Now, maybe, guys, you'll tell me in chapter 5, he always gives us the mean and the standard deviation. But actually, instead, chapter 5, we assume that we know them. But in reality, guys, we don't know the mean and the standard deviation of the population. You don't. So in chapter 6, we assume that we don't know them and we try to estimate them. Assume that the population standard deviation is known to be 10.2. What is this, guys?
Sigma.
Sigma. And look at the title of this section, guys. Estimation for the mean of a population standard deviation known. So sigma. given. Not S, sigma. All right. I'm gonna walk you step by step. Even if it takes me half an hour, guys, to do this exercise, I'm willing to spend the time because I want you to learn it and learn it very, very well. Because once you learn this exercise, the rest of them, guys, are just very similar to this one. So list the given values, sample size. I'm gonna list them one more time, guys. 25. Sample mean, X bar is what? 81.5. Okay, here I made a mistake. It's not a sample standard deviation, population standard deviation. You know, the way I create this handout, guys, I cut and paste, and sometimes I forget to change a word here or there. So population standard deviation, sigma. Confidence level, guys, C is what? 95%. Are we good so far? Please, any questions? Ask me, guys, before I continue, because I'm going to show you how to construct the interval and find the interval. All right. We said this is the interval. You can memorize this. It's X bar minus E and X bar plus E. So mean is X bar. I know X bar already. At least you get some partial credit, guys, if you just write this. And 81.5 plus E. Need to find E. And let's show you how to find E. I'm going to do it on a separate sheet of paper. And then I'll go back, just to the actual handout. So E, this is the formula for E. You don't need to memorize it, guys. This is the formula that we put for E. Sigma we know, which is what, guys? 10.2. N we know, which is 25. So what remains to find, guys, in order to find E? Z. All I need to show you how to find this value, guys. If I can show you how to find these values, you are done. You just take this value, multiply by 10.2, and divide by square root of 25, and you get E. You go back and put it in here, minus E plus E, and then you get your interval, and you are all done. So actually, guys, the key point when finding the confidence intervals is to find this Z value, which I'm going to show you a visual. What is that Z value that I'm talking about? So this is always known, guys. This value is always known. This value is always known. The only one that's unknown is this one. In the book, he called it Z with the C next to it. That means that Z relates to the confidence level. So actually, the actual formula in the book is like this, guys. That's the formula. Okay, please give me a minute to show you that Z value, and I'm sure one of you will be able to help me find it using technology. That's a good news. We're going to use technology to find Z. Okay, what's the confidence level in this problem is 95% confidence. So this is the 95%. This is the confidence region. Okay, so we have 95% confidence region. What percent is not a confidence region?
5%.
5%. And you guys, since this is a confidence interval, it has a lower bound and upper bound. That 5% is split on two sides. Right here and right here. So what's the area right here, guys?
2.5%.
2.5%. which is 0.025 if you like. And this one, guys, you don't need to do this to find Z, but I need to show you the first time a visual, just spend time on it, but you're gonna see how easy it is to find Z later. Let me tell you what Z is. Z is the value that splits up the confidence region from the non-confidence region. So Z is this value right here or right there. This is 0. This is the Z line. This is the mean 0, and this is Z. And actually Z is two values, one positive and one negative. But once you find one, you're all good. Does anyone, so this is your ZC right here. One is a negative and one is a positive. And it is called a critical value. Why they call it a critical value? They call it a critical value because it splits up, separates the confidence region from the non-confidence region. So what is this Z value? Does anyone know how to find this? What do I do to find this value? From chapter 5. What do I use? It's a number. How am I gonna find this number? So I have the probability to the left, the area to the left, and I need, to find the Z-score. What feature do I use on the calculator, guys?
Inverse norm.
Inverse norm. That's it. And put the area to the left, 0.025, comma 0, comma 1, and that should give you the Z. Let's do it. Let me get my calculator. Okay, you're ready? So second, distribute, inverse norm. You put the area 0.025, you put 0.1, and you get negative, for 2 decimal places, guys, Z is rounded to 2 decimal places, negative 1.96. Any guess, guys, what this one is going to be? They're symmetric. Yeah. Let's say a student said, well, Mr. Bazi, I don't want to find this, I want to find that. No problem. Let's define this one. The area to the right is 0.025. What would be the area to the left of this, guys?
0.075.
975. Because you subtract 100% minus 2.5%. And watch, guys. But I wouldn't advise you to do it twice, guys. You already done the work. Just do it once. 0.97501, paste. There you go, 1.96. It's enough to do the -1 and you're all set. So in summary, guys, I'm gonna show you a shortcut and how to find those Z critical values, ZC values, and plug them into E by doing the following. Please pay attention. Here's what you do. How to find ZC. You go to inverse norm and you do this. You do 1 minus C divided by 2, comma 0, comma 1. Let me explain what I meant by that. Let's say your confidence level is 90%. So you do 1 minus 90%, or if you want to do it as 100% minus C, but change 90% to a decimal. So 90% to a decimal is 0.9. Do 1 minus 0.9, it will give you 0.1 divided by 2, and then comma 0, comma 1. What did we do here? 0.95. Subtract 0.95 from 1, guys. What do we get? 0.05. Divided by 2, what do we get? 0.025. So that's the rule, guys. You can, I'm going to write it down, just on the guided notebook, but that's a rule how to find ZC. To find the other value, guys, don't do no work, just change the sign. This is gonna give you the -1. For the other one, you just change the sign, it will be the positive one. So this is how you find ZC. And let me, all right, so let's go back and continue our exercise. Okay. I said find ZC using table 4. If you don't want to use the table, you want to use your calculator, guys, that's fine. So we're going to find ZC. So ZC, it's going to be, I'm going to write it down here. Inverse norm, we already did it. 1 minus 0.95 divided by 2, comma 0, comma 1, and we guys got negative 1.96. Okay? Calculate the margin of error E. That should be ZC here. Now, you get a negative number, but when you calculate the margin of error, guys, don't use the negative sign. Just use the positive sign, because eventually you're going to add E and subtract E, so it doesn't matter, but always use the positive one. So it's going to be 1.645. Sorry, 1.96. I made a mistake. Times sigma. What is sigma? 10.2 divided by square root of n, which is square root of 25. Okay, guys, can you take 30 seconds to compute this for me, please? That's the algebra that we did earlier. Okay, what's the answer?
4.00.
Yeah, it's 4. And now let's take the page. Mean is between X bar, which is 81.5. We're almost done, guys. Minus 4 and 81.5 plus 4. So mean is between 81.5 minus 4 is 77.5. And this is 85.5. And this is your confidence interval. How do you interpret this to a reader, guys? So the question was, construct a 95% confidence interval for the population mean mu. Assume that the population has a normal distribution. A sample of 25 randomly English measures has a mean test score of 81.5. Assume population standard deviation is known to be 10.2. So it's about the English measures and their mean test score. So here's how you interpret for a reader. And this is very important. For someone who doesn't know statistics, guys, this is not going to mean nothing to them. So how would you interpret this? So this is what you say. And I put the blanks here. Can someone guess what I'm going to put here? Interpret the answer in words.
95%.
With 95% confidence. Don't make up your own language for this, guys. It's going to be pretty much the same throughout, the book or the chapter. We can say that the true mean test score for English measures is between whatever we got, 77.5 and 85.5. And why it is important to mention the confidence level, because you're telling the reader that you're not 100% sure. You are only 95% confident that the mean test score is between 77.5 and 85.5, but not 100%. So it's always, what they do in the polls, guys, they don't mention the confidence level sometimes. And the reason why they don't mention it, pay attention from now till the election, guys, and count how many times, they mention the confidence level. They don't mention it because people don't understand it. They don't know what it means. But there are times they're honest. They state the confidence level when they announce, poll results. So this is the confidence interval. I think probably, guys, you're curious to see how we can use the calculator to find this. So you're ready? All that work that we have done, we could have done it in less than 1 minute using the calculator. So get ready. We're going to clear the screen. We're gonna press the stat key. From now on, guys, from chapter 6 onward till the end, it's gonna be stat and tests. And then I'm gonna show you where we're heading for section 6.1. Any guess? It's on this screen.
Z interval.
Z interval, we're working with Z. It is Z interval. When the population standard deviation is known, he gives us sigma, it is Z interval. That's the feature for section 6.1. Press enter. Okay. I have summary. Okay, input. Let me explain the difference between the two. Either you have data or you have a summary. When you have data, he will list the raw data. He didn't give me any raw data here, so it's a summary. So by default, usually it should be on this stats. What is sigma, guys? What was sigma in the problem? 10 point. That's what I meant, guys. It's important to be able to distinguish the variables. So to know how to input this into the calculator. X bar was it? It was 81.5. N was 25, and the calculator needs to know the confidence level. For the confidence level, guys, you can put 95 or you can put 0.95. I think the calculator will take it either way. And actually, guys, you're expecting the answer to be exactly what we have. Let's see. Ready? Hit calculate. And here's your interval. 77.5, 85. If you round it to one decimal place, 85.5. Watch, guys. Perfect match. Any questions? All right. We're gonna do this exercise, example 1, using the calculator, and show you how you could find the interval. So in example 1, suppose from a random sample of size 49, so take notes, guys, this is N. We find a sample mean of 30, that's X bar. It's known that the typical distance value is from the population standard deviation is 35. He's giving you the population standard deviation, that's sigma. Compute a 95% confidence interval, that's C. And this is all you need, guys, to plug it into the calculator. I did it, I'm showing you the work here. I'm gonna use it using TI-84 right there, because we don't have time anyway to go through this. TI-84. Okay, so it's gonna be Z interval, guys, just to remind you. Let's do this. Ready? Let's do it together. So you go stat, tests, Z test, sorry, Z interval, not Z test, not yet. And then let's input. Sigma is 35. Oops. Watch. X bar is 30. N is 49. And the confidence level, leave it the same. Ready? And let's see if our answer is gonna match with the work that I've done. 20.2, 39.8. Watch, guys. So what's your preference, using the calculator or showing the work? And if to show the work, guys, you just need to find E. This is E, that's it. And then you add it to X bar and you subtract it from X bar. I did it, all together, but E will turn out to be 9.8 if you are to find E. And then you do 30 minus 9.8 and 30 plus 9.8, and you get the interval. And look the statement, guys, you have to learn how to write the statement. With 95% confidence, we can say that the population mean is between $20.20 and 39.8. Okay, so this is almost 75% of section 6.1. I needed to spend time, guys, to introduce the confidence interval concept, but we will be able to finish the entire chapter next time we meet, because we already have an idea what an interval is, and then the calculator is going to support us in completing this chapter. So you can start working on homework from this section already. I'm going to stop here. I'm going to go to Socrates, just a couple questions to answer before I let you go.